We all know that Julia is a language designed for numerical computing, and it does that job pretty well. I'm here to talk about applying Julia to a different domain, and that is Julia for infrastructure. Right? By infrastructure, I mean things that keep the lights on, mission-critical stuff like databases, key value stores, file systems, stuff like that. So I've been developing infrastructure software for 17 years now, mostly in C, C++, and occasionally assembly language. I want to tell you a story of how I was converted to being a Julia user, and I also want to share the story of my colleagues and I at Keenant. And I want to tell you how we use Julia in our little startup and how Julia can be a competitive advantage for startups. So at Keenant, we're developing a data governance platform. So it automatically generates a data map of data in an organization. And you can query for stuff like, is data accessible to people who are not supposed to access the data? But I'm not here to talk about that. I'm here to talk about our journey in getting here. So we pivoted a couple of times before we got to where we are today. And this talk is going to be a story of our journey. So when we started off, we wanted to build something that people would use, right? So we had this idea of doing compression at scale. It was a method to find redundancies in petabytes of data, right? So we went about writing a prototype in C. And the reason we wrote it in C was I had an eternity of experience in C, and every problem looked like it had an elegant solution in C, right? So we wrote it in C, but I'd like you guys to stare at the screen for a few seconds. The problem with writing in C is that it takes a long time to write stuff, right? Fortunately, I developed stuff in Emacs, and I was exposed to Lisp. So I love Lisp. Lisp is a beautiful language which allows you to write programs succinctly. And I was looking for something like Lisp. At one point, I even thought that we would develop in one of the commercial versions of Lisp. In late 2016, I read an article about Julia, and just for fun, I rewrote the most computationally intensive part in Julia. And to my surprise, when we ran our micro benchmarks, it ran as fast as C, so that was really surprising. So then we rewrote all our stuff in Julia. That took about 2 weeks to do. So once we did that, we had to go out and find users, right? So we started talking to users, and that's when we realized that we were not solving a pressing problem. Storage was getting cheaper every year, and with the advent of cloud storage, people were not really bothered about storage costs anymore. So it didn't make sense selling something that improved storage efficiency. So then we scrambled and we got together and put our heads together to figure out what we needed to do next. We figured that people would want something like a data ubiquity platform. And what I mean by that is something like Git for large data sets. So we started developing that, and in 2 months we had a prototype, right? Even that didn't work out. But had we developed stuff in C or C++, we would have completed that in November, and we would have kind of exhausted half our runway. So my co-founders and I have about 2 years to get this working. And switching to Julia actually reduced our probability of failure by a fair amount. So if nothing else, startups should adopt Julia just for this reason, that they can iterate quickly. So I'd next like to talk about what we developed, right? So it was a system that had a file system interface, which could be extended to a SQL kind of thing, if required. We have an oplog that replicates operations to multiple nodes, and that's used for high availability. The oplog is also used like a heartbeat. So if the secondary node fails to get a request, right, it would try to take over. So the system we developed was, we wanted it to be something like Git for large data sets. We wanted it to have capabilities like quick checkpointing, quick cloning, and restarting on different nodes. So this was more like a file system gateway, in the sense that it was a persistent cache for hot data, and data was tiered to S3 for long-term retention. So while building the system, I get asked this question, why did we use Julia rather than some other programming language, right? So for guys coming from Python land, it's not something interesting, but coming from languages like C, C++, or even Go, where you don't have a REPL, right? The REPL is like a debugger that has the expressive power of the language itself. And also, the REPL helped us to prototype stuff quickly. And combined with the level of abstraction that Julia provides, right? So 10 lines of Julia code can do a lot compared to other languages like C or C++. And on-disk formats can be a big deal when you're developing things like databases or file systems. The problem is that once you write data structures to disk and you ship a product, it's almost impossible to kind of change it. So that's why you have structures in ext2 that are there in ext3 and carried over to ext4, right? So some commercial systems have tried to solve this by versioning the data structures on disk, but the code can get really messy and a lot of bugs creep in. So what usually happens is that someone forgets to update the version numbers, and just before we release the product, the upgrade tests fail, right? And the whole release is put on hold. So in Julia, this is easy because we use Julia's powerful introspection capabilities, right? And we just dispatch the data structures from disk to the right function using multiple dispatch. So a big problem in the industry gets solved using very simple code. So I remember in a place that I worked, there used to be a steward whose responsibility was to check that everybody updated the on-disk versions, right, whenever they checked in code. So with Julia, you don't need all that. So I talked about the distributed op log for high availability. With Julia, we just implemented that with the remote call. Of course, there's some code to check for heartbeats and take over the system. But in other languages, this usually will turn out to be a project in itself. So we use tasks a lot because infrastructure systems generally are kind of servers that take requests, right? And we use tasks to improve throughput and reduce latency. Now coming to challenges, the lack of threads was the biggest challenge that we faced. Any software that takes requests, that's a server, I think needs some kind of multi-threading. The workaround that we used was we used thread call, but it's not an elegant solution because we had to port a lot of code from C back to Julia. Sorry, from Julia back to C, right? Because thread call calls into a C library. The other thing was buffer bloat. So any software that takes requests in a loop tends to allocate a lot of memory to service the requests. The solution we used was a ring buffer. This is not a problem with the language itself, it's just a design pattern. The other thing is when we ship commercial products, we don't want to ship the source code, and it's kind of not intuitive to do that with Julia. I'm hoping that PKG3 will solve that problem. And finally, language instability. I think that's a common complaint about Julia, but I guess we just have to wait till version 1. So in summary, Julia is great for infrastructure projects, but I think once we have multi-threading working in Julia, that would be a point after which there'll be an explosion of the use of Julia for infrastructure. And Julia is awesome for startups, and it can mean faster iteration cycles and probably the difference between life and death for a startup. So you can contact me at these addresses. Now I'm open for questions.